Hello, in this video we will focus on type 2 errors and the power test with Python. So first we will talk a little bit about hypothesis testing. So for example, here is a test on the population mean, and we have null hypothesis H0, which is a hypothesis that the population mean value equals a specific value. So here we use mu1 equals mu2. And we have alternative hypothesis, which is to reject this null hypothesis. So here, the alternative hypothesis is mu1 not equals to mu2. And we get the sample statistics and make a test based on the test statistic is in the critical region or not in the critical region. So this is the basics of hypothesis testing. Then here we will focus on the type 2 error. So what is the type 2 error? So if you think about one question, that's how much chance that we have to reject the null hypothesis when the alternative is in fact true. So if we look at these two statements again. So null hypothesis, the name is null, which means it has no sum effect. And H1, which means that we have to reject null hypothesis, which means that we find the sum effect. So you can say we are more interested in H1 than H0. So if we get H1 and reject H0, which means we find the sum effect. And if the H1 is true, and how much the chance that you can find this effect and reject null hypothesis, then this is like the power of test. And on the other side, if the alternative is in fact true, but you did not reject the null hypothesis, so you make an error. And this error is type 2 error. We call it the beta. So which means that the result is true because the null hypothesis is false, but you did not reject it. So the power of a statistical test is 1 minus beta. So 1 minus beta times 100. So we call this here is times 100. So for example, beta is 0.2. So type 2 error is 0.2. Then we get 80% of the chance that you can reject the null hypothesis and accept a true alternative hypothesis. So this is the power of test. So if we look at further this figure, so if null hypothesis is true, which means, for example, the population mean is 0, then you get the test statistic from the sample will follow this figure, follow this curve, right? And if you get the data in this blue region, then you will reject this null hypothesis. But in this case, because the null hypothesis is true and you reject it, you make a type 1 error. So we mark here with a blue chance of type 1 error, which means the null hypothesis is true, but you get the very critical data from the sample. Very strange data. So you reject it, but you make an error. And the other case is that the alternative hypothesis is true. So which means we have a mean value from population not equal to 0. We get here 2 equals 2. And you get the sample data follows this red curve, and you get the data if in the blue region you did not reject it. So you get the fail. But here in the red region you reject the null hypothesis and you accept this alternative hypothesis. Then this is the power in this red region, right? So determine the power of a statistical test and the calculation of the minimum sample size required to reveal an effect of a given magnitude is called power analysis. So this statement includes 4 factors. The first is alpha, which is type 1 error we have seen, which means we reject a true null hypothesis. This is error. And the beta is the type 2 error, which is that we did not reject a failed null hypothesis. And the third is the D, or we call the effect size. So effect size is project specific. So different tests, for example, for the population mean, for the population variance, or other kinds of tests, they have different meaning of the effect size. These have different magnitudes. But generally, this magnitude can be compared with the standard deviation of the sample. So this is called effect size. And the fourth is the sample size. So usually, bigger sample will be much more powerful, and a smaller sample will be less powerful to find an effect. And anyway, for these 4 factors, we know the 3 of them, then the other one will be defined automatically. And in Python, we can use function to calculate and do the power analysis. For example, we can, after we have imported the power module from stats module stats, then we can use the function called tt_int solve power to get the number of observations, which means the minimum sample size required to find an effect with 0.5 and with alpha and power 0.8. Then we go to Python, import this module from stats module stats. Then say we want to get the minimum sample size if we want to get 80% of the power in a test, and with the significance level, which means alpha or the type 1 error controlled at 0.05, and we will find effect size with 0.5. Then we can use this function and with the input all the other 3 information. So the minimum sample size you required is about 64 for each group, because here we used group to group. Then next example shows how much the effect size you can find in a power test with the 0.05 for type 1 error alpha. Then you will get at least 80% of the power to find this effect, and with the sample size for each group is 25. So we can also use this function power.tt in the solve power. So now the effect size you will find is about 0.8. So this is the effect minimum you can find, which means there at least has this kind of effect or difference between 2 groups. And this means this is 80% of standard deviation of the sample. So this effect size is same as 81% of the sample standard deviation. Thanks for watching.